something strange is happening about 350 million kilometers from Earth, a place where sunlight is faint and the rules of physics are supposed to stay unbroken. But this time, they didn't. Astronomers recently detected an object hurtling toward the sun that refuses to behave like anything we've ever seen. It's moving through space with a precision that seems almost intentional, ejecting materials that defy chemistry itself. Even stranger, its tail, that long glowing streak every comet should have, isn't pointing away from the sun. It's pointing toward it. To scientists, that's not just weird, it's impossible. Comet tails are shaped by solar radiation and the solar wind, powerful streams of charged particles that always push debris away from the sun. That's been an unshakable law of celestial physics since the first comet was ever studied. But this one, nicknamed 3I Atlas, seems to have decided it's done following the rules. Early data show the object is ejecting gas and dust in the opposite direction of every other known comet. And that's only the beginning of its strangeness. Its chemical composition doesn't make sense. Its trajectory seems too precise to be random, and one Harvard scientist estimates there's only a 0.2% chance that its current path happened naturally. That means there's a 99.8% chance something else is going on, something we might not be ready to understand. And in just a few days, we'll know if 3I Atlas is a comet, or something completely different. Because whatever it is, it's not just visiting our solar system, it's rewriting what we thought we knew about it. When the twin telescopes in the Canary Islands first locked onto 3I Atlas, astronomers noticed something that didn't fit any known pattern. Instead of a comet's familiar tail streaming away from the sun, this one stretched in the opposite direction, pointing straight toward it. To understand how strange that is, picture a windsock at an airport. The solar wind works the same way. It blows particles away from the sun, shaping a comet's tail like a cosmic breeze. But 3I Atlas ignored that wind entirely. It seemed to be pushing against it. Scientists started calling it an anti-tail, and the term stuck because no one could offer a better explanation. At first, most experts tried to brush it off as an optical illusion, or a trick of perspective, the kind of explanation that calms everyone down. But one person wasn't convinced. Professor Avi Loeb from Harvard, known for his bold takes on interstellar mysteries, pointed out that this wasn't a photographic glitch. The data were clear. The tail was reversed, and that meant something physical, not visual, was happening. Loeb argued that none of the usual comet mechanisms could cause this. Outgassing jets, solar radiation, even magnetic effects. None fit the data. He compared the situation to finding a compass that points south. It's not supposed to happen, and pretending it's normal doesn't make it less strange. Even more unsettling? The anti-tail isn't the only anomaly. 3I Atlas is ejecting nickel without iron, an impossible combination in nature, since the two elements are chemically linked. It also navigated through our solar system almost invisibly, slipping past planetary detection networks as if it knew exactly where not to be seen. Loeb says when you combine all of that, the anti-tail, the missing iron, the unlikely orbit, it forms a pattern. And patterns, he argues, don't happen by accident. They point to design. But the mainstream community isn't ready to hear that. Most astronomers are calling 3I Atlas a highly unusual comet, hoping the mystery fades once more data arrives. Still, a few are starting to whisper what no one wants to say out loud. What if this isn't a comet at all? As scientists dug deeper into the data, the list of impossible details kept growing. Each one alone could be dismissed as a glitch, but together they painted a picture that refused to make sense. First, there was the nickel without iron, something that shouldn't exist outside of a lab. Every natural process that produces nickel in space also produces iron. The two elements are cosmic twins, born together in the hearts of dying stars. But 3I Atlas seems to have been forged differently, as if its maker, whoever or whatever that might be, separated the metals on purpose. Then came the trajectory problem. Astronomers ran the numbers and one conclusion stood out. The path of 3I Atlas has only a 0.2% chance of being natural. That's not a small statistical error, that's practically a cosmic red flag. It entered our solar system on a near-perfect approach, threading through the gravitational pulls of Venus, Mars, and Jupiter with a precision no random object should have. It's as if it plotted its own course. Add to that its age and speed. 3i Atlas is older than our solar system, moving faster than any known comet, and glowing with a deep green hue that's brighter and purer than expected. Every observation adds another layer of contradiction. NASA's instruments show it's ejecting huge amounts of nickel, but without the corresponding chemical partners. Its shape, long and cylindrical, stands out against the lumpy, uneven rocks we normally see drifting through space. Even its surface reflections suggest a level of uniformity that feels engineered rather than natural. At this point, some scientists quietly admit that the data looks less like a comet and more like something built. But official reports avoid that language entirely. Instead, they call it unusual, enigmatic, or under further investigation. In truth, no one knows what 3i Atlas really is. A relic from another solar system? A fragment of something artificial? Or just nature showing us that our definitions are too small? Whatever the answer, one thing is certain. The deeper researchers look, the more impossible it gets. And as NASA prepares to release its official classification, one question looms over the scientific community. Are they explaining the mystery, or covering it up? Despite all the anomalies, NASA's official statement was simple. 3i Atlas is a natural interstellar comet. No alarms, no speculation, no theories about alien technology, just calm scientific language and quiet confidence. They've reviewed the same data, the strange chemistry, the reverse tail, the bizarre trajectory, and yet they insist that everything can be explained by chance and natural processes. To them, this is an extraordinary but natural visitor, but some wonder if that's really what they believe, or if it's just the safer answer. Throughout history, scientific institutions have resisted disruptive ideas. It's not stubbornness, it's protection. Extraordinary claims demand extraordinary evidence, and until every other explanation is exhausted, the extraordinary is ignored. But sometimes that caution turns into denial. When something doesn't fit, it's easier to file it away under unexplained than to admit it might rewrite textbooks. A few researchers quietly admit that NASA's stance might not come from certainty, but from caution. Because if this object turns out to be artificial, the implications go far beyond science. It would mean the first confirmed evidence that we are not alone, and not everyone's ready for that conversation. NASA is still watching. The European Space Agency's JUICE probe will also be observing 3i Atlas over the next few months. If it's truly a comet, the heat from the sun will soon cause it to fragment, break apart and vaporize, the usual fate of icy visitors. But if it doesn't, then the world will have to confront something far stranger than anyone expected. As the object moved closer to the sun, the mystery deepened. Instruments aboard the Swift telescope detected something completely unexpected. Water vapor, about 40 kilograms every second. To put that in perspective, that's 41-litre bottles of water evaporating every single second, over 100,000 litres an hour. The problem? 3i Atlas was way too far from the sun for that to be happening. At its distance, the sunlight is barely strong enough to warm a rock, let alone vaporize ice. Ordinary comets don't release that kind of water until they're much closer, inside what's known as the activation zone. But 3i Atlas was acting like it was already boiling, as if something inside it was generating heat. Some scientists proposed that maybe it contained radioactive materials deep within, slowly decaying and heating the core. Others suggested exotic ices, chemicals that evaporate at extremely low temperatures. But none of those explanations fit perfectly. The numbers just don't add up. Then came the discovery that left everyone stunned. Nickel tetracarbonyl, a toxic compound that, on Earth, is only found in industrial processes, specifically in metal refining. It forms under high pressure and precise conditions, not in the random chaos of space. Finding it inside an interstellar object was beyond strange. It implied the presence of metallic nickel reacting with carbon monoxide in an environment that mimicked a factory, not a frozen rock. That detail sent shockwaves through the small community of researchers paying attention. Because if those readings were correct, 3I Atlas wasn't just behaving differently, it was producing chemicals that shouldn't exist naturally at all. So what's more likely? That a random piece of space debris somehow mimicked industrial chemistry, or that we're looking at something with an engineered interior? That's when one theory started gaining attention, a theory that sounded less like science fiction and more like the only explanation left. Harvard's Avi Loeb didn't hesitate to say what others were thinking, but too afraid to voice. What if 3I Atlas isn't a comet at all? His idea was simple and terrifying. He proposed that this object could be an ancient mothership, possibly launched billions of years ago by a civilization long gone. Not necessarily active, not necessarily hostile, but built. The shape fits. Long, cylindrical and consistent, not the irregular rock shapes typical of comets. The anti-tail could be exhaust or propulsion residue, not vapor. The nickel emission might be a byproduct of energy generation or self-maintenance. The outgassing could be venting, or even coolant release. And the trajectory? Perfectly aligned for a gravitational assist maneuver, the same trick human spacecraft used to slingshot around planets and conserve energy. Loeb pointed out that the object's approach toward the Sun happens at the exact angle that would allow it to accelerate and change direction efficiently, something a natural comet wouldn't care about, but an intelligent probe might plan. He even went further. If 3I Atlas is a mothership, it could deploy smaller probes, scout craft that detach, linger, and observe. They'd be too small and too quiet for our instruments to detect, especially if they were designed to hide. Humanity could be surrounded by interstellar visitors right now and have no idea. Most scientists rolled their eyes at the theory. They called it sensational, speculative, and unsupported. But Loeb isn't just a fringe thinker. He's one of Harvard's most respected astrophysicists, and he's willing to stake his career on the idea that our skies might be more crowded than we realize. Because, as he puts it, dismissing the impossible doesn't make it go away. And if 3I Atlas doesn't break apart when it nears the Sun, if it survives that inferno, then Loeb's theory becomes a lot harder to ignore. Every story needs a moment of truth, and for 3I Atlas that moment is October 29th. The day it makes its closest approach to the Sun, a point astronomers call perihelion. This is the test that will decide everything. If the object is truly a comet, the heat will be unbearable. Solar radiation will strike its surface at full force, melting ices and building internal pressure until the entire structure cracks apart. That's the predictable natural outcome. Dozens of comets have met their end this way, vaporized in spectacular cosmic displays. But if 3I Atlas doesn't fragment, if it holds together under that intense heat and stress, then something else is happening. Comets aren't strong. They're fragile snowballs held together by dust and frozen gases. To survive that kind of energy, an object would need to be far more solid, more engineered. There's another reason this date matters. When 3I Atlas passes behind the Sun from Earth's perspective, it becomes invisible to nearly every telescope on the planet. That's also the window when any kind of maneuver, acceleration, rotation, or probe release could happen unseen. A few researchers even suggest that this timing feels too perfect. If someone, or something, wanted to perform a controlled maneuver while hidden from human observation, this would be the ideal moment to do it. By early November, the object will re-emerge from behind the Sun, and we'll finally see what survived. If it's broken, the story ends. But if it's still intact, the story changes forever. Even before the perihelion, something about 3I Atlas's path raised eyebrows across the scientific community. The odds that it entered our solar system naturally on this exact trajectory are about 0.2%. That's 1 in 500. Think about that. Across the vastness of interstellar space, this object just happens to fly directly through the narrow orbital plane where every major planet resides. Statistically, it should have approached from a random angle, above, below, anywhere but here. Instead, it arrived almost perfectly aligned with the solar system's plane, moving opposite the direction of the planets, as if it wanted a better view. To mission planners at NASA, that's the kind of orbit you'd choose intentionally if you were trying to observe or map our planetary system. It's the most efficient path for gathering data on multiple worlds in one pass. Could it be luck? Sure, space is chaotic. Randomness happens. But if this were the only anomaly, no one would care. Combine it with the anti-tail, the industrial chemicals, the missing iron, and the unexplained outgassing, and coincidence starts to look a lot like design. Even stranger, the object's speed variations don't match gravity's pull perfectly. Tiny fluctuations, subtle but measurable, suggest active control or directed venting. Natural? Maybe. Intentional? Possibly. But either way, it's not behaving like the thousands of comets catalogued before it. A pattern is emerging, one that challenges everything we thought we knew about celestial mechanics. Either nature just pulled off a 1 in a billion performance, or something else is guiding 3i Atlas on purpose. As the evidence builds, so does the divide, not just between scientists, but between institutions and the public. In observatories and academic papers, the tone is cautious. Researchers use phrases like unusual but explainable, or an interesting case study. Behind closed doors, though, some of those same experts admit they're baffled. The math isn't clean, the chemistry doesn't fit, the energy output defies the models. Meanwhile, the internet is exploding with theories. Amateur astronomers are posting live updates, sharing telescope images, comparing notes in forums. Some say the green glow around the object is too bright to be natural. Others claim to see structural patterns in the light curves, repeating signals that don't look random. On social media, 3i Atlas has become a global obsession. To some, it's a scientific miracle. To others, it's the first step toward confirmation that we're not alone. Hashtags trend, rumors spread, and videos dissect every new observation frame by frame. And as the conversation grows louder, NASA and the European Space Agency stay quiet, releasing data but avoiding speculation. That silence only fuels the fire. Because when information is withheld, people fill the gaps with imagination. Professor Loeb calls it the silence of comfort. He believes institutions fear the social shock that would follow even a hint of non-human technology. Funding would shift, governments would panic, and public trust could fracture. So instead, they say nothing. But silence doesn't stop curiosity. If anything, it amplifies it. And as 3i Atlas closes in on the sun, millions of eyes are watching, waiting to see whether the universe is about to reveal one of its oldest secrets, or remind us how little we really understand. Let's imagine just for a moment that Avi Loeb is right, that 3i Atlas isn't a comet, but something older and smarter. Maybe it was built by a civilization that no longer exists, launched billions of years ago to wander the galaxy long after its creators were gone. A silent messenger, still performing its mission long after its home star went dark. If that's true, then we're not witnessing an accident of physics. We're witnessing design. A piece of technology so ancient and resilient that it's outlasted entire civilizations. And now, by pure coincidence, it's passing through our neighborhood. The implications are staggering. Overnight, every field of science would have to rethink its assumptions. Governments would scramble to investigate. Space agencies would reallocate resources. And humanity, for the first time, would know, beyond all doubt, that we are not alone. But even if it were true, there's a sobering reality. We wouldn't be able to communicate with it. If it's automated, it may not even recognize us as intelligent. If it's powered down, it could simply drift past, a relic of something we'll never understand. Some scientists compare it to finding an ancient shipwreck in the middle of the ocean, perfectly preserved but without a crew, a monument to something that once was. Others take the idea further. They ask, what if this isn't the first visitor? What if similar probes have passed by unnoticed? What if our detection systems are so limited that we've been surrounded by interstellar artifacts for centuries, never realizing what they were? These are questions too big for comfort, but impossible to ignore. Because whether it's a coincidence of chemistry or a product of intelligence, 3i Atlas is proof of one thing. The universe still holds secrets that make us question everything we think we know. And as the countdown to perihelion ticks closer, the world is holding its breath. The final hours before October 29th feel like the calm before a storm. Around the world, telescopes are trained on a single point of light moving across the dark canvas of space. Every minute brings new readings, new questions, and the same overwhelming tension. Will 3i Atlas survive? Scientists are preparing for both outcomes. If it fragments, the story ends neatly. A comet, strange but natural, destroyed by solar heat like so many before it. But if it holds together, if it emerges intact from its fiery encounter, then everything changes. The natural explanations collapse, and humanity will have to face a question that's lingered since the dawn of civilization. Are we truly alone? Across social media, live feeds are counting down the hours. Amateur astronomers are staying up through the night, scanning for any sign of a breakup or flare. News anchors are calling it the moment of truth. And somewhere in a quiet Harvard office, Avi Loeb waits, knowing that whatever happens, his career, and maybe human history, will never be the same. If 3i Atlas is natural, science learns. If it's not, humanity awakens. Either way, October 29th will mark a turning point. The day an interstellar visitor forced us to look deeper, to question harder, and to realize that maybe, just maybe, we've never been alone at all. Because sometimes, the most extraordinary discoveries don't come from what we find in the universe, but from what refuses to be explained.